Hello students, after completing the topic which is reflection at the surface of a solid, where we had the value of B1 in terms of E1, B1 was complex, and we have defined the value of alpha R and alpha T, will move forward with the very important definition, I should say, which is the standing wave patterns. Now you very well know how do you get a standing wave. So this is suppose my normal wave, a sine wave. Okay, so here suppose I draw a wave like this exactly. Okay, so this will be called a standing wave, and you know this is my node position and this is the anti-node position. Fine. So this is my standing wave. What we are trying to talk about, that suppose, as we mentioned earlier, the first derivation in this module 2, okay, we did two derivation. Okay, in the first case what we said, suppose you had a fluid medium and transmission from one fluid medium to another fluid medium. So what we said in that case, that suppose you have this boundary O dash, okay, which was at x is equal to 0. This is medium 1, this is medium 2, rho 1 C1 is a characteristic impedance, rho 2 C2 is a characteristic impedance. This is the first derivation we did, found out the value of alpha R and alpha T. Second derivation what we did use the boundary, okay, and we said that the plane wave is hitting this boundary and other side you have a solid instead of a fluid. Okay, so in that case when we say that you have got the incident wave, okay, after hitting it you are going to get the reflected wave. So this is my incident wave, reflected wave. So in this case we found out only in medium 1 the value of alpha R, and from alpha R we got the value of alpha T, because alpha T is 1 minus alpha R. Fine. Now when I am defining this, what I need to say first, how do you get the standing wave? Standing wave is nothing but the formation of a reflected wave at any plane boundary of a fluid medium will generate a pattern of standing waves in the fluid. Okay, which means this is the fluid medium. So I say this is my incident wave and this is the reflected wave. So this pattern will be like this. Suppose I say incident wave. So here I get my reflected wave. So this is my standing wave pattern at the boundary. Again I'll repeat, the formation of a reflected wave at any point, at any plane boundary of a fluid medium will generate a pattern of standing waves in the fluid. So when this happens, so when the pressure amplitude constant, what we said, B1 is for the reflected wave and A1 is for the incident wave. Fine. So when the pressure amplitude constant complex B1 of the reflected wave is complex, okay, then it is possible to show by methods, okay, which we discussed earlier, that the amplitude P1. So now see in your notes where we have got the equation for P1 before defining alpha R and alpha T in this module itself. Okay, one more thing I want to tell you, that see to it that the moment I upload the video on my YouTube channel, your duty is to watch the video within next 48 hours. The video is hardly for 20 minutes. That much time you should almost find any particular day. Okay, it's not difficult. If it is difficult, see to it that you find time. And don't forget to write the comment, your name in the comment section. If you don't write, I'll mark you that you didn't see it. Okay, so don't ask me later how and why. Don't unnecessarily check my patience. I am observing hardly few names every time. So if it is the case continuation, no worries. Okay, I am announcing one more thing. I do everything in the video only, so if you do not watch it, you will miss it. I will be taking a test on end of this month, might be 30th or 31st, on module 1 and 2 complete. I might declare the syllabus by 20th. Whatever I finish by 20th, I'll take it in the test. Okay, so if you do not watch this video also, you will miss it. I will not help you out. I will not repeat this. The test will be of 15 marks or 20 marks, not decided, but the test is there. Okay, so see to it that you'll watch the video and do not forget to write your name in the comment section. Otherwise, absent. This is the last and the final warning. Get it? Okay. Now the equation. This equation I wrote it before I defined alpha r and alpha t during this derivation. So what was the value I wrote there? I wrote A1. A1 is what? Amplitude of the incident wave plus B1 bracket square cos square. There I wrote cos square k1x. Here I am writing cos square k1x plus theta by 2. Correct? Plus A1 minus complex B1 bracket square sin square k1x plus theta by 2 full bracket raised to half. This equation I wrote it already, but there theta by 2 was not there. See before alpha r and alpha t definitions. Fine. Now what is theta over here? Theta here is the plane angle. What is this theta defined as? So theta will be defined over here in the expression for my complex B1. So I can say complex B1 is equal to real B1 a to the power I theta. So I'll say this is my equation number 1 and this is my equation number 2. Okay. So what I got over here? I got the value of, in short, the pressure. Okay. I got the value of pressure. So here I reached. Now what I need to say over here now, that this angle theta basically measures the amount by which the reflected pressure, okay, at the surface of a solid leads or lags the incident pressure, obviously. So suppose what you say, that is my incident wave is going further than the reflected wave, so either it is leading or lagging. That's what it will be able to measure. So angle theta measures the amount by which the reflected pressure at the surface of a solid leads or lags the incident pressure. Okay. Now how will where will be this will be of help? Once I know the value of antinode or node, then it will be of some help in this case. So now we will try and define one more thing, which is called as SWR, which is the standing wave ratio. Pattern is okay, but how will I measure? How will I get the value of this or this? That is also important. So for that, what we need to do, if suppose one can determine both the magnitude and the phase of the reflected pressure. Magnitude, this is incident wave. Suppose this is reflected wave. Okay, the R is over here, R is over here. So suppose one can determine both the magnitude and the phase of the reflected pressure amplitude. Means what? B1. Okay, relative to incident pressure amplitude, that is A1. Correct? Where we got this relation in the last derivation, what I taught you. So what was the relation I taught you last time? Zn is equal to A1 plus complex B1 divided by A1 minus complex B1 into rho 1 C1. This I taught in the last lecture itself. Okay, not far off. This is the relation. Okay, so yeah, A1 plus B1 upon A1 minus B1 rho 1 C1. Okay, so I can write this Zn, complex Zn itself. Done. Now this is suppose my equation number 3. Now I say that the magnitude of B1 relative to A1, okay, is determined by what? Determined by the standing wave ratio. This equation everybody knows. That's this we discussed last time. Agreed? So the magnitude of B1 relative to A1. Now I am writing normal B1. Why? Because I want the magnitude. So I don't have to write the complex B1. So the magnitude of B1 relative to A1 is determined by the measurement of SWR, that is standing wave ratio. Fine. So how it is defined? It is defined as, so I'll write over here, SWR is equal to ratio of pressure amplitude at an antinode. I'll write over here, pressure amplitude at antinode divided by pressure amplitude at a node. Here I should say at an antinode. So what is the value of at antinode? Antinode will be A1 plus B1. Okay, but as I am writing magnitude, I will not write the value. I'll write A1 plus B1 divided by A1 minus B1. Okay, the reason for writing normal, because I need magnitude. The reason I am writing here B1 because this was the complex, like as it is hitting and then reflecting back, that's why I used to write over here, and pressure being the scalar quantity, we used to write it in the complex pattern. Fine. So what is my definition of SWR? I'll write it over here again. SWR is basically A1 plus B1 divided by A1 minus B1. Very, very important relation, equation number 4. Fine. Now, what will I do? I'll try and subtract minus 1 from SWR. Okay, means what? I'll write SWR minus 1. Okay, so here also I write A1 plus B1 upon A1 minus B1 minus 1. Okay, how much this will be? This will be A1 plus B1 as it is, minus this term will come over here, A1 minus B1 divided by A1 minus B. So what will get cancelled over here? A1 get cancelled, and this will become 2B1 divided by A1 minus B1. Fine. Similarly, if at all I add plus 1, so SWR plus 1 is equal to A1 plus B1 upon A1 minus B1 plus 1. Okay, what will I do over here then? I'll write A1 plus B1, as it is plus sign, I do not have to bother. Directly I can write A1 minus B1, so cancel B1, this is 2A1 by A1 minus B1. Okay, so now suppose I write the value, okay, SWR minus 1 minus divided by SWR plus 1. Okay, minus 1 value is how much? 2B1 divided by A1 minus B1 multiplied by, this term will come below, so I'll write A1 minus B1 upon 2A1. This gets cancelled, 2 gets cancelled, so I have B1 upon A1 in which I am interested. What I need basically? I need B1 upon A1. Fine. So I can use this formula, basically equation number 5. Okay. So by measuring the position of either